series combination of resistor. What it means? I'm going to connect some resistor in series. Look at this. Let's say these are some resistor, and resistance of these resistor are different. Let's say its resistance is R1, and resistance of second one is R2, and resistance of third one is R3. Their resistance is different, and we know that resistance means the obstruction offered by the conductor wire against the flow of current through it is called resistance of that substance, and the substance having high resistance is called resistor. And this is the combination of, I'm talking about combination of resistor. Let's say first resistor is connected to second, and second is connected to third. How we are connecting? When resistors are connected in with each other, due to which if we pass current through it, then the same current passes through it. If I is the current and it is 1 ampere, the same 1 ampere passes through first resistor also, and the same passes through second also, third also. That's why definition may be when resistors are connected in with each other, due to which same current passes through each of them, then the combination of resistor is called series combination of resistor. Now this is the diagram to represent series combination. Now I want to talk about the characteristic of this combination of resistor. Characteristic of combination of resistor. As I told you just now, if there is no any other path for the flow of current, single path, then the same current flows through each of them. That's why it can be taken as one of the characteristic of series combination of resistor. We can say that same current flows through each of the resistor in this type of combination. Now next, let's say this is a point, let's say it is A, and this point is B, and this point is C, and this one is D. Let's say I'm taking different points on this combination, and these two terminals are if connected to a battery, then the current flows through each of the resistor. Now I want to measure potential difference or voltage in different places. Voltmeter is a device which can be used to measure potential difference or voltage. If we connect voltmeter at these 2 points, voltmeter is if connected, then it measures total potential difference. Let's say total potential difference is V, maybe 10 volt or 5 volt or 6 volt, whatever it is, total potential difference is V. Now disconnect this and connect the same voltmeter at these 2 points, A and B. When we connect voltmeter at A and B, then we are going to measure now PD across first resistor. Potential difference or voltage across this first resistor. Let's say its value is V1. Now disconnect it again. We are doing so very practically, and if the same is connected to these 2 points BC, when voltmeter is connected to these 2 points BC, then we are going to measure potential difference across this second resistor or voltage across the second resistor. At this time, let's say value of potential difference is V2. Now in the same way, if we disconnect and connect at these 2 points C and D, then we are measuring potential difference across third resistor. Let's say this is V3. Now we have different values. There are 4 values taken, and if we see this value, then what is found? The sum of these 3 values, V1, V2, V3. I mean to say PD across first resistor, PD across second resistor, and PD across third resistor. When sum of these 3 is taken, it is found to be equal with the total potential difference PD between A and D. What it means? We can conclude that in this combination, total potential difference is equal to sum of the potential difference across each resistor. Mathematically, here I have written, mathematically V equal to V1 plus V2 plus V3, and if there are other also, we can write them also. The meaning is very simple. In this series combination of resistor, total potential difference is equal to sum of the potential difference across each resistor. We can get it by measuring potential difference across all these, whatever I told just now. Now next thing, all we know that V equal to IR. This is Ohm's law. Potential difference is equal to current into resistance. If it is so, now let's fit this equation here. Potential difference between A and D is, if taken as V, total potential difference, then the total current is I and the total resistance is R. If it is so, now for first resistor, what happens? Potential difference across first resistor, I told you V1, second resistor it is V2, and third resistor it is V3. Now the same equation, in case of first resistor, same equation can be written this way: PD across first resistor, which is V1, is equal to current in first resistor is same I, and resistance of the first resistor is R. In the same way, let's talk about second resistor. PD across the second resistor, it means PD between B and C, which is denoted by V2, then V2 is equal to, now current flowing through this is equal to current flowing through this also the same current, that's why I am writing I, and resistance of this second resistor is R2. Now let's talk about third one. But PD across third resistor is V3, previously told, and PD across this third resistor is V3, and current flowing through this is also the same current I, and resistance of this resistor is R3. Now we can take this value here. In place of V, I can write IR. In V1, in case of V1, I R1, and in case of V2, I R2, in case of V2, I R2, and in case of this V3, I R3, I R3. If there are other, we can take other values also plus this. Now, if we go forward, this way I can be taken as common R1 plus R2 plus R3 and so on. Now, I cancel, therefore the conclusion is R equal to R1 plus R2 plus R3 and so on. Look at this is another conclusion. What can we see? In series combination of resistance, this total resistance is equal to sum of the resistance of individual resistor. I mean to say total resistance is equal to sum of the resistance of each resistor. R1 plus R2 plus R3 is equal to total resistance R. If total resistance is 10 ohm, then maybe here 2 ohm, 3 ohm, 5 ohm, 2 plus 3 plus 5 becomes 10. This way, we can say that total resistance is equal to the sum of the resistance of each resistor mathematically R equal to R1 plus R2 plus R3 and so on. This way, I told you a little more about the series combination of resistors. Let's recall all these. When resistors are connected end to end with each other, due to which same current flows through each of them, then the combination is called series combination of resistors. You can draw this diagram to show series combination. And characteristic, in this combination, same current flows through each of the resistor. One characteristic. Another, in this combination, voltage divides among the resistor, and total voltage is equal to sum of the voltage across each resistor, or we can say PD across each resistor. Now, third characteristic, in this combination, total resistance is equal to sum of the resistance of each resistor.